Assalamu alaikum. We know vector quantity possesses both magnitude and direction. In this video, we will discuss about different types of vectors. First, we will discuss about equal vectors. Equal vectors. Now, for example, if we have two vectors, vector A and vector B, then these two vectors are said to be equal when they are represented by a line having same length and acting in the same direction. So in simple, I can say two vectors are said to be equal when they have same magnitude and acting in the same direction. And there is one more condition for vectors to be called as equal vector is they must represent the same physical quantity. So let me show this to you with the help of a diagram. So suppose this line represents a vector A and this represents a vector B. Now, if you look at these two, you may find both of them are acting in the same direction, and they are of equal length. So, we can say their vector A and vector B are nothing but equal vectors. And I told you there is one more condition for vectors to be called as equal vector is they must represent the same physical quantity. If vector A represents weight, means B should also represent the same physical quantity. Got it? Now, under equal vector, we come across one more type of vector called as collinear vector. What is that? Let me explain you. The first type. Collinear vectors. If two vectors are acting the same line, then we call such vectors as collinear vector. And one more condition is the angle between these two vectors may be either 0 degree or 180 degree. How is it so? Let me explain this to you. Now, if you look at the name itself gives its meaning. Here we have the term co. Here co represents common. This stands for common. And linear stands for line. So, vectors which are present in the same or common line are referred as collinear vectors. Or something like this. Suppose there is a line. Now it represents a vector A. And the same line, vector B is also present. Means here vector A and vector B are referred as collinear vectors. Okay, and here if you measure the angle between vector A and vector B, you will find this to be equal to 0 degree. Here the angle is 0 degree. So it satisfies the condition, and so A and B vector are referred as collinear vectors. I told you the angle may be 0 degree or 180 degree. So how such collinear vectors with the 180 degree angle will appear? Let me show this to you. See, suppose this is the vector A acts in this direction. Then vector B acts in the opposite direction. But both of them are present in the same line. Then here, see, the angle between them, angle between vector A and vector B is nothing but 180 degree. Here the angle is 180 degree. So both of them are referred as collinear vectors. Now under them, see, it is not necessary for collinear vectors to act in the same line. Now there are certain vectors, they are not present in the same line. Now suppose I have a kind of vector called as the parallel vectors. Parallel vectors. Now what is this parallel vector, or what is meant by parallel vectors? Let me tell you. Parallel vectors are those which act in the same direction but shown by different lines. Suppose here I have vector A. This is another line. This is vector B. Now these two vectors are acting in the same direction and shown by two different lines, but these two lines go parallel to each other, so they are called as parallel vectors. So then I'll tell you what is meant by anti-parallel vectors. Another type, anti-parallel vectors. Anti-parallel vectors are those which act in opposite direction. Now, say vector A. Suppose vector act in this direction. Then I have one more vector. Let's see, vector B. It is found that it acts in the opposite direction. So, though they are parallel to each other, the lines on which they are present are parallel to each other, but they act in the opposite direction. So we can say they are anti-parallel vectors. Correct? So next we have unit vectors. Second type is unit vector. Type 2, unit vector. Now before going ahead, I would like to add a few more points about these two vectors. Now if you look at parallel vectors carefully, you may find the angle between them is nothing but 0 degree, because they are acting in the same direction, and the angle between anti-parallel vectors nothing but 180 degree, as they are acting in the opposite direction. Now what is this unit vector? Here unit has come from the word unity. Here unity stands for 1. Stands for 1. Vectors whose magnitude is equal to 1 but possess some direction is referred as unit vector. Vectors whose magnitude is equal to 1. Magnitude is equal to 1 is referred as unit vector. How do you represent a unit vector? A unit vector is represented by a special symbol. Now suppose I have A as unit vector. If it represents unit vector, then it will be provided with a special symbol. This symbol stands for unit vector and it is read as cap. This this symbol is called as cap or hat. So how will we read this? It is read as A cap or A hat. And it represents a unit vector. Got it? Now, as I told you earlier, a unit vector have got magnitude equal to 1. And how one can obtain unit vector from a given vector quantity? Now, suppose I have a vector by name B vector. Now this is a vector quantity, and I want to get a unit vector from this. For this, what has to be done is unit vector, this b cap. This can be obtained by dividing b vector with its magnitude. So b vector divided by magnitude of, that is modulus of b vector. I told you earlier, when we draw two parallel lines around a vector quantity, it represents the magnitude. This modulus of b vector is nothing but modulus of magnitude of b. Clear? This is how, by dividing a vector quantity with its magnitude, one get a unit vector. So from this it is clear that if you multiply a unit vector with its magnitude, you will get a vector quantity. Okay, so that particular quantity will get a direction. Clear? You remember this, it will be useful in a 12th of physics. Clear? Now, under unit vector, we come across certain things called as orthogonal vectors. Orthogonal vectors. Orthogonal vectors. Orthogonal vectors are nothing but type of unit vectors, but the certain properties they possess. What are they? Let me tell you. Here, these orthogonal vectors are usually represent letter I vector, I cap, j cap, and k cap. And they are shown along x axis, y axis, and z axis. Something like this. Coordinate system. This represents x axis, this represents y axis, this represents z axis. What is so? The unit vector which acts along x axis is referred as I cap, and the unit vector which acts along y axis is referred as j cap, and the unit vector which acts along z axis is referred as k cap. Here I cap, j cap, and k cap are nothing but orthogonal vectors. Now, if you take any two orthogonal vectors, suppose I take j and k, you will find the angle between them is nothing but 90 degree. I repeat, the angle between any two orthogonal vectors is nothing but 90 degree. So, angle between I cap and j cap is equal to 90 degree. In a similar way, angle between j cap and k cap is again 90 degree. In a similar way, the angle between k and I, k cap and I cap is again 90 degree. Now, if you look at this diagram carefully, you may find the angle between j and cap is obviously 90 degree. But how it could be 90 degree? How the angle between I cap and j cap can be of 90 degree? Let me tell you. Here, when you draw a cross line, something like this, it means actually to represent a coordinate system, we have to draw three lines perpendicular to each other. So in such case, we can draw two lines which are acting perpendicular to each other. It is not possible for us to draw another line which acts perpendicular to both the y-axis and the z-axis. In such case, what we do? We draw a line which is inclined to y-axis and z-axis. Okay. Actually, we have to draw a line which is projecting outward, something like this, in the direction of this chalk piece. But it is not possible to draw one such line on this blackboard. So we draw an inclined line. This inclined line actually represents a line which is projecting outward. I think you have understood. So this is all about different types of vectors. Now there is one more type of vector is present. About that I will tell you after rubbing the board. The other type of vector is nothing but zero vector. The third type is zero vector. What is the zero vector? Zero vector is nothing but a vector whose magnitude is equal to 0. So this is a zero vector. Here, this kind of vectors have magnitude equal to 0, and what about their direction? Listen to me carefully. Zero vectors have unknown direction. They have unknown direction. It means they end from a point from where it start. Suppose I call this as the starting point of a zero vector. Then this zero vector will end at the same point. So the direction of zero vector is unknown. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.